So hello everyone. This is a recording for experiment number 5, encoder and decoder. So the aim of our experiment here is to design and implement encoder and decoder using logic gates. So for the sake of simplicity, we are considering a 4 to 2 line encoder, and the combinational design is explained using a block diagram. So basically in a 4 to 2 line encoder, there are total of 4 inputs and 2 outputs. The 4 inputs being y0, y1, y2 and y3, and the outputs are a0 and a1. So this is the truth table of the inputs and outputs. We'll just get back here once we move on to the simulation part. Here we have the logical expression of the term a0 and a1, which is basically obtained by getting the values of a0 and a1 at places where they are 0 and the corresponding input values. So that's a logical expression. And here is the circuit design. The components used in the circuit are 3 input switches and 2 OR gates. Now let's move on to the simulation part where we verify the truth table using a simulator. So as mentioned, we have the components used, 3 input switches, 2 OR gates, and I've also used additionally 2 bulbs in order to represent the state of the gates. So as we could see, when I have not used another input y3, as the outputs for the corresponding input is anyways gonna be 0. So we are starting with y2, y1 and y0. So when y2 is turned on, we could see a0 has the value 1, so a0 is enabled. And when y1 is enabled, we could see a1 is enabled. And finally, when y0 is enabled, we could see both a1 and a0 turned on. That is, they both have the state 1 and 1, which is basically on. So that's encoder. Now let's move on to the decoder part. So yeah, here we are using a 2 to 4 line decoder, and the combinational design is explained using a block diagram. So here basically we have a total of 3 inputs and 4 outputs, and the third input being the enable pin, which basically is mostly on whenever we have an output. So that's the reason why it's called a 2 to 4 line encoder. So whenever you have an output, there's the enable pin is definitely gonna be on, or the state is going to be 1. So the input variables here are a0, a1 and the enable pin, and the outputs are y0, y1, y2 and y3. So here is the truth table, which will be just looking after once we go to the simulation. And here is the logical expression as the one similar to which we just went through. So the circuit design basically involves 2 input switches, 2 NOT gates and 4 AND gates. So now let's move on to the simulation part and verify the truth table. So as I mentioned earlier, here we have all the components listed as before: 2 input switches, 2 NOT gates and 4 AND gates, and additional of 4 bulbs just in order to represent the state of the gates. So let's start with the default inputs. So as I said earlier, when the enable pin is 0, we don't get any output. So for all outputs, for every positive output, there's gonna be the enable pin is gonna be enabled. Enable pin is gonna have the value 1. So when both the values are when both the inputs are 0, we could see that y0 is enabled. So this is the y0 as per my design. So when both the inputs are 0, y0 is 1. So when a0 is turned on, we could see y1 is enabled, or the y1 value is turned on to 1. When the next case being a1 enabled. So when a1 is enabled and a0 is disabled, we could see the output of y2 to be on. And finally, when both a1 and a0 are enabled, we could see that y3 is enabled. So that's the simulation for decoder. Thank you.